Okay, let's talk about section 6.4, which is on inverse trig functions. So up until this point, we have only worked with sine, cosine, tangent, secant, cosecant, and cotangent when given an angle. So we have found things like sine of 30 degrees, which we know is 1/2 if you think about a 30, 60, 90 triangle. So what we're working on today is what if I know the ratio and I want to find the angle? So going backwards. That's what an inverse is. Addition, subtraction. They are two functions, two operations that undo each other. So today we're looking at how do you undo a trig function, and that's these inverse ratios. So these are the notation that you're going to see for inverse: sine to the -1, cos to the -1, tan to the -1. Just a side note, these can also be written as arc sine of x or arc tan of x, arc cos of x. That's just another notation. So if you're watching, maybe searching a different video for some extra help, realize that arc tan, arc sine, arc cos, those mean the same thing. So inverse sine of x equals y, that means that the sine of y equal x. So it's asking you sine of what angle y will equal x. So it's giving you the ratio and asking you for the angle that goes with it. Here's a great example. Inverse sine 1/2 equals 30. Right here, that means the sine of 30 equals 1/2. So it's just asking you, given the ratio, what is the angle? Now, one of the really tricky things about the inverse trig functions is that they have very specific and restricted domains. And there's a lot of reasons for this. I think it's just easiest to understand right now in our limited space for explanation and for question and answer that you just need to know these domains and ranges. So when you're talking about an inverse sine or an inverse cosine, your domains are talking about, these are all talking about ratios. So the domain of inverse sine, inverse cosine is -1 to 1 because your sine and cosine ratios are restricted to values between -1 and 1. There's something over hypotenuse, and so that means that they're always going to be less than 1. Tangent has a domain that's anything because I can have an inverse tan or a tangent ratio of anything. So my inverse tan domain can be whatever I want it to be. Ranges are very specific. So when you're talking about the range, meaning the answers that come out of an inverse sine or an inverse cos or an inverse tan, they're very specific. So the range of inverse sine is always going to be between -90 and 90. So the answer is always going to be between -90 and 90 degrees. Notice that inverse tangent is also the same thing. It's always giving me either a fourth quadrant negative answer, like 0 to -90, or a first quadrant positive answer, 0 to 90. Now notice right here that cosine is different. Cosine gives me an answer between 0 and 180. So my answer for cosine is always going to come between 0, could be equal to 0, and 180 degrees. Now the reason for that is that cosine is positive both in first and fourth quadrant. And so if I do an inverse cosine in the fourth quadrant, it's not a positive value. It's already positive, it's not negative. That's the main issue. Now that piece right there is really confusing, and because it's different from one trig function to another. So to help us out, here is kind of a table that I would work from. So if you have the inverse sine of a positive ratio, so if the question's something like inverse sine, I'm going to make my thing a little bit smaller here as we're talking. So if I'm doing inverse sine of something like +1/2, if the question is inverse sine of +1, if the number that you're asked for the inverse sine is positive, then your answer is always going to be between 0 degrees and 90. If I'm talking radians, that's always going to be between 0 and pi over 2. if you're doing the inverse sine of a negative value. Okay, so if we're saying inverse sine of -1/2, if we talk inverse sine of -1, now the fact that the sine is negative means that it can't be a first quadrant angle. Sine isn't positive in the first quadrant. If you remember from last week, we talked about all students take calculus or all students take classes or whatever you want to choose. Sine is positive in the first and the second. And so inverse sine of a negative is going to come from the fourth quadrant. So your answer is either going to be between -90 and 0 or -π/2 and 0, depending on radians versus degrees. Now, the nice thing is tangent has the same two sets of answers. So if I'm going to ask for something like tan inverse of 1 or tan inverse of maybe radical 2/2, then those are going to give me these same two answers. I'm just going to copy this. I'm going to copy them both because they're both going to correspond. If I switch this to a negative, if I do tan inverse -1 or tan inverse negative radical 2/2, then I'm going to get an answer in the fourth quadrant negative. Now, the thing to remember about these is when I talk about trig ratios, there's an infinite number of angles that have a trig ratio of 1, like a tan ratio of 1. There's an infinite number of ratios or of angles that give me a tan ratio of radical 2/2. We are looking for one specific value. We want everyone to answer this question the same way, and that's why we have these restricted ranges. And it is confusing because they're different depending on which trig ratio you're looking like, and we're not used to working with negative angles if we don't have to. But realize that the sine inverse positive is the same as the sine inverse, or the cos inverse of a positive ratio. The sine inverse of a negative ratio is the same as a tangent ratio. Now, cosine, these two are going to be different. If I ask for a cos inverse of a positive ratio, like cos inverse 1/2, cos inverse 1, that actually is going to be the same as the other two. Positive ratios always give me something in the first quadrant. It's nice and easy to work with, between 0 and 90 or between 0 and π/2. Cos inverse that's negative, that's where it's different. So if I do cos inverse of a -1/2 or cos inverse of a -1, I can't use that fourth quadrant angle because the fourth quadrant angle between -90 and 0, cosine's is positive there. The other two trig ratios are negative in the fourth quadrant, but cosine's not. And so for that reason, this becomes between 90 and 180, or between π/2 radians and pi radians. So one thing I recommend is, this is not all that straightforward. It is confusing. This chart can help you. So kind of refer back to this to help out. The second thing that's going to help you is we've included this table of exact values. So notice that you have all of your trig ratios here. So sine through cosecant. We have all of our angles up here. These angles are in radians, so let's do a quick conversion. So if we're talking radians, π/6, well, this is 0 degrees. π/6 is 30 degrees. π/4 is 45 degrees. π/3 is 60 degrees. π/2 is 90. Pi is 180, and 3π/2 is 270. So if I had asked you last week to find the tangent of π/4, you probably would have started with a 45, 45, 90, which looked like this, pi over 4, 1, 1, radical 2. And then you might have said opposite over hypotenuse is 1 over 1, which is 1. Now we can say tangent 45, and there's our value of 1. So part of the reason we're doing this is because with the online school from this pandemic, it's just not as easy. And this is not the easiest concept. And so we're giving you a little bit of a crutch to work with, and that's this chart. We would have introduced this chart later on in the year, but we thought it would be helpful to introduce it today to help us with these pieces. So I'm going to cut this out so that we can reference it in the next couple questions. So I'm going to copy and we'll come down here and do some examples.